Hello everybody and welcome back. In the previous video we finished adding a layer of persistent storage. However, when we stopped last time, things were not looking really good for the use tasks store hook. Actually, it's looking pretty bad and things are pretty ugly here. So our goal in this video is to apply some of the good design principles we know to fix the problems in this hook. So what is looking ugly here? Well, to begin with, this use tasks store is okay. Let's go to the thing that is annoying me the most is this inline function here. I can just extract this into an async method. Okay, so I'm just going to let me just take it here and we're gonna say this const create task, and that's just going to be async, so we can actually get rid of this whole bunch of things here. We don't need promises anymore because they get converted to promises behind the scenes. And now here we have they get converted to promises behind the scenes because we're using the async keyword. Okay, so that is the first thing that I want to get rid of. This is looking much better and it's much cleaner now. So this was the first one. And remember, refactoring should always take us from a working code from a stage of working code to another stage of working code. That was the first problem that I had in mind. But the second problem, and the more serious one, is that the use tasks store is tightly coupled to our persistent storage solution. We are calling local storage here directly. And we already know that local storage is not our final solution here. We already know that eventually we want to have a remote server and we want to have a way of interacting with that remote server. So the problem here is that once I add the remote server and then if I start adding local storage all over the place, what happens is I need to go all over the place to change from local storage to the remote server. So this use tasks store is actually tightly coupled to the storage solution, which is not what we want. What we want is to have these things decoupled. We just want to have we just want to interact with the interface of any persistent storage solution. So what we will do is we'll just extract all this logic here. We're going to extract also all this logic here to a separate set of methods, which will then be made available to us here. And we will be able to use them in our tasks store without really having to call the local storage within this hook. How we're going to do that is within the data stores here, we can create a new file. And again, it's not a problem where we create it because refactoring for moving files is not a big problem here in the project. So let's call this, it's going to be local storage persistent storage. Okay, so that's just that's quite repetitive, but it gives the clear notion that this is a persistent storage. So now we're going to do something which is pretty cool. What we're going to do is we'll create a class here. So basically the steps. Okay, so I'm just going to write the steps here. The first step that we're going to implement is that we will create an interface. Okay, an interface for persistent storage. Okay, so that is the first thing that we want to create, an interface. And actually, can I just add an export here so you shut up? Yeah, okay, now it's better. So we don't have a bunch of squiggly red lines. So the first step is to create this interface for the persistent storage. The second step is to implement, right? The local storage persistent storage class, which implements the interface. Okay, so we'll first create an interface, then we implement the local storage class, which implements the interface, and then the final step, we create a bunch of functions which receive a persistent storage and allow us to decouple, right? To decouple things. Okay, so this is extremely high level, and for the next maybe, I don't know, 15 minutes. No, it's bad to estimate the time because here when I'm recording is different than when I'm actually in the end of the editing. But in the next few minutes, that's what we will do. So here, let's create an interface. The first one is going to be, I'm going to call it interface, and this interface is going to be a persistent storage interface, right? So we can even add the I here to indicate that this is a persistent storage interface. So which kind of methods do we want to have in this persistent storage interface? Or actually we can say here even task persistent storage, right? So this is clearly a tasks persistent storage interface. This will have the methods to interact with a tasks like whatever, if it's local storage or whatever it is remote, this will have the methods to interact with this. And the first one is we want to get all tasks. Okay, this is just going to be a method which will return a bunch of tasks for us. Right, so now that I have the import here, I can get rid of this. That's good. This is just TypeScript complaining that it's not a module, but anyway. So we get all the tasks and we also want to save all tasks. Okay, and the save all tasks here receives an array of tasks and it returns. And actually, let's make everything async friendly here by using promises right from the beginning. Right, this is not necessary, but we will do so. Or, I mean, it's not necessary for now because local storage is synchronous, but we will still do this just for us to have a more robust setup, because many of the storage solutions that are available out there, they're asynchronous, so we would work with promises nonetheless. So this interface actually reflects pretty much what we have here, right? So the get all tasks is the load all tasks, and the save all tasks is basically the update all tasks. It reflects the two things that we have here, and now we can use this interface to implement a local storage persistent storage. So here we will simply say we will export a class called local storage persistent storage, which implements the iTasks persistent storage, right? So now here, the idea is that the local storage persistent storage is not specific for tasks. It can have tasks, but it can also handle other things. It could handle projects, it could handle configuration, it could handle other stuff. And then we would have a bunch of different interfaces that it needs to implement so that it can have this additional functionality. Good, so we do need to implement both methods, right? So we do have the get all tasks here. And we do have the save all tasks, but you see that this is complaining because it's not returning what it's supposed to return, right? So this we would mark as an async method, and we can again use the arrow functions here, or I don't think we can. Oh no, we cannot. Can we? Actually, the async is in the wrong place. Sorry for that. The async should be here, and everything should be good to go. Now here, if we actually return just a new task, that would stop complaining, but I need to pass a title here, so mock. Right? And that should actually be an array. So here we would return something like this, and then it stops complaining. Right? All right. So here we still didn't manage to make any test fail yet. It's still fine. It's still working. I know this is not the final implementation, but now I'm just worried with the types. Okay. So now here we'll say save all tasks, which is again an async that just receives my tasks and does nothing for the moment. Okay, and then here I do need to pass the type as well, or actually I'm not sure if I need to pass the type, but yeah, so it's basically just saying that tasks implicitly has an any type. So here that's going to be tasks like so. Oh, sorry, task like so. And then the only warning comes that it's never used. So I can actually make an underscore here, and then everything is fine for us to go. Right, so if I have here and then a colon here, there's a bunch of empty, it's probably, yeah, unexpected empty async method, but nonetheless, we have implemented a first version of this. So the first step here is done, right? The second one is in progress, And what we will do now is we'll just take the code here and we will actually copy paste. So basically what we will do is we copy paste here. We say that again, the JSON tasks are this, right? So that is JSON tasks here. And then what we will do is we will simply return a JSON tasks dot map like so. So we're just going to return this stuff here, and that's still working fine. So now here you see that we have two imports from the models. We can actually come here into the index and we can also export the serialized. Actually, I think I can do both here. Serialized task and task. Okay. And what is re-exporting a type of the is provided the export type. Okay, so now here I actually need to have maybe slightly different. Let me have a look. Is the export type serialized task from dot task, right? Like so. And then everything is fine here, and I can come back and I can actually have the serialized task and the task here from the same imports or from the same module, and I don't need to have a bunch of inputs to actually do the same thing. Okay, so the next step is let's then move this here also into our function. So we actually have it here, and we'll simply say tasks. We're going to remove the underscore, and actually now all our basically all our warnings are gone. Now, once again, I took a very big step here, and I actually did write a lot of code that is not tested in my local storage persistent store. So I'm just going to remove everything again. And there you have it. Actually, let's go back to how it was before, blah, 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 blah. And there you go. And here, basically, I'm not allowed to write anything that does not let me test this, or that is not covered by a test, right? So let's create a new file that's going to be called local storage persistent storage.ts. Oh, actually .test.ts. And then here we'll simply say describe tests the local storage persistent storage behavior. Okay. So that's going to be, again, a few things here. And what we want to do is we want to say const. And basically, I think that here we will need to, again, interact with the local storage, right? So we need to make sure that we have a before each, and we clear up the local storage, dot clear. And again, we are writing the tests here basically just because we can do so, because we have direct access to our local storage. If we were doing this, if we were writing these tests in a network setup, we would probably mock the network response, and then we would simply test how the methods actually behave. Okay, but for us here, because we have control over the local storage, we can actually go a little bit further and test this in our code. So it should correctly load, or let's say it should correctly persist. Okay, let's start with the load first. It should correctly load tasks from the local storage tasks tasks key. Okay. So what I'm going to do here is I will simply say local storage dot set item tasks, and I'm going to pass here a JSON dot stringify an array with a simple task. We know that this task has an ID of 1, 2, 3 and a title of how do we call it? How can we call it? Mock task, right? So here we can also use something that's called a fixture. Like that's very simple fixture. We're gonna say here just this task, and because we want to have a bit of type confidence here, we wanna have some type safety. So what we're gonna do is we'll simply say const mock task is going to be of type serialized task, and this is going to be just like so. Okay, so this gives us a more interesting, or this gives us a bit more type safety. So now we can actually pass this mock task here. So we're simply setting the item task. So we are setting the local storage before we actually interact with the class that interacts with it. And basically now here we'll simply say const local storage persistent storage is equal to new local storage persistent storage. Okay, so basically now I am getting the task here, and I want to get const all tasks is equal to local storage dot get all tasks. This is still working, and then here we would expect all tasks to have a length of 1, and we would also expect all tasks 0 dot get identifier, right, to be 1, 2, 3. Okay, so now it's we can also actually this mock task here is not the best way. Let's refactor this to have a small cap, and then here we'll simply say mock task dot id. Okay, so this is allowing us, and then here it is complaining that it has actually we need to await here. Sorry for that. And that's going to be async because we need to await, and now exactly we have it not get identifier. Perfect, right? So it was missing an await, so it was working with the promise itself. That's a slide. That's one of the benefits of our type safety and of using TypeScript. So once I save this, let's see if this is going to work. And as expected, that's good. It doesn't work because we are actually just retrieving or returning a mock task here. So now we can actually just come here and use this to our tests. Okay, so here basically, again, I'm not going full TDD here because if I were to go full TDD, that would be maybe a simpler solution, but I'm also leveraging the fact that we already know a little bit of how our solution is going to work. Okay, so once I now fix this and save this, that should also pass the tests. Good, now everything is passing. We can come to the next step here where is it? Where is my test? Here, that's my test. It should correctly store tasks in the local storage tasks key. Okay, this is again async because we will work with async methods here. And basically what I want to do is I just want to create a task. So const my task is equal to new task. Oh, where is this text coming from? I don't know. New task, and here I'll simply say persisted task. Okay, now what I want to do is I just want to pass this to my local storage. So once again, I get the const local storage persistent storage, like so, and I say await, right? So now I'm just gonna await things to save here, local storage dot save all tasks, and then I can simply pass my task here, right? And now here what I would do is I would actually interact with the local storage. So I would say local storage dot get item tasks, and then we would parse whatever we get back. We could also use the local storage persistent storage, so that's also fine because we are testing the behavior of it on the top here. So simply say persisted tasks, and I'm just using the local storage here so the persistent storage to actually not have to do like all the loading from the local storage and then parsing it and then transforming it and so on and so forth. So we would simply say get all tasks, and we would expect the persisted tasks dot to have length of 1. And again, I'm missing the await here. I'm missing the await. And we would also expect the persisted tasks 0 dot get title to be here. That's going to be persisted task, right? Like so. So now once I save this, our tests should fail, right? Because now we have no body whatsoever in save all tasks, and this thing is just not going to do anything. This method is not going to do anything, and our tests will fail. So now again, we have the permission to come here, copy this, paste this here within our method, and we should be good to go, except that I need to remove the underscore. Once I save this, now that should be good to go. The tests should start to pass. Oops, there is just a small mistake here. Let me show you. It's pointing that we are actually receiving a function. So I just forgot to call it. Once I save this, then now everything should be in order. Perfect. Now we have a more robust test setup that also tests some of the behavior of our local storage persistent storage. Again, this is like kind of tricky because we can interact with the local storage here because this is in our like local setup, is in our control. But if this was a network request, we would mock these things. Okay, we would mock the network request and mock the response. And then we would also write tests for different responses. We would want to have tests for a successful response, a 2xx response, and for an error, for example, 5xx response. So we would like to cover all that in the test. Here, because it's a very simple API, we don't need to worry about it that much. Important thing is that we get the habit of always thinking in terms of tests as being our enablers to actually write code or to actually write production code. Good. So the second step here is actually done as well. We do have the local storage persistent storage class, which implements the interface. Now the next step is we actually want to replace whatever we have here with that local storage. So one first thing that we can actually do here is to simply say const local storage persistent storage, right? Or we could even say just persistent storage is equal to new local storage persistent storage. And then here what we will do is, instead of doing it like so, we would simply say that would be here now we have an async method, so that would persistent storage dot get all tasks dot then, and then we would have the tasks here, and these tasks will simply set the tasks to whatever tasks we receive back. Okay, now why do I need to use the then here? And that's because the use effect does not accept async methods. Okay, if I put async here, you'll see that it starts complaining and it says it does not allow this, right? So it has to be a void here, which means that we just don't get anything, right? So no, we don't get anything. It just means that we cannot use the await inside here. We do need to use the traditional then. Okay, I'm just going to add a few new lines here if it allows me to do so. It doesn't. Okay, all right, too bad. Then let's fix this and let's leave this as it is. So now it is a much cleaner, and actually here we have now a dependency on the persistent storage. Maybe even a more correct way, as you can see here, it's pointing out that we would have to like wrap this around the use memo because it is a dependency of this. So what we can actually do is we can also move this outside of our function, and then the dependency here can go away, because the persistent storage is something that does not depend on our UI. This is just a class that we use to interact with the local storage. We don't need to create it, and actually we shouldn't create it inside of a component, right? So now here we have a use effect that allows us to use the persistent storage to get all the tasks and then set the tasks here. Now let's have a look if this is passing, if everything is still working as expected, and I do believe it is, because we haven't changed anything in terms of behavior. And once again here, once we have the use effect, we can now say that persistent storage dot save all tasks with our tasks. Okay, now here it complains, it says that we are not doing anything, but we actually don't need to do anything here. We just want to save all the tasks whenever the tasks update. So this is just something we'll leave as it is. This squiggly line here doesn't mean there is any error. It just means you don't do anything with the result of save all tasks, and that's perfectly fine for now. All right, this is looking much better than what it was before, because now we could simply swap this local storage persistent storage with another type of interface here, or another type of persistent storage, and everything would still work as expected. Now, the problem here, and it's a smaller problem this time, but still, if I were to actually change this with a task, okay, just like so, let's say I'm going to create a new task here, mock, right? You see that we start getting these errors here all over the place. Now, I'm using the persistent storage only in one place, which means that I would have to substitute all the methods here only in one place, or not substitute, but at least address the errors. The problem is that when we start using this persistent storage all over the place, and we maybe do a mistake and we forget to implement a method, or we change the interface and we want to actually make sure that we update the code to that new interface, and we need to go all over the place to change all the calls that we do to the methods of the persistent storage interface. So there is still some coupling here, and we want to get rid of this. Now, the way to get rid of this is to actually move this coupling into a single place. Where are we going to do that? We're going to actually create a couple of functions that we will, we could even create them here, that's fine, and that we will use as kind of a proxy. So these functions will receive a persistent storage, and they will receive whatever other information they need, and they will just invoke the respective method of the persistent storage. So here it's just going to be, I'm going to call it like so, save all tasks, or actually let's say get all tasks. That is fine. Okay. It can have the same name, it's not a problem, but here I'm just interested in receiving a persistent storage, which is of the type I, or actually, it's not local storage. What is the interface again? Here, I tasks persistent storage. So it's this one, and I do need to export stuff from here. And I also want to, no, this is at the same level, so that's fine. Now I can import it here. So what I need is a persistent storage of type itasks persistent storage, and then here we don't need to get anything else because we're not saving anything. This is an async method, and all I'm going to do here is I'm just going to return persistent storage.getAllTasks. Okay, so now the idea here is that what I'm doing once I call the getAllTasks, like so, you see that now we actually need to pass the persistent storage that we have here, and then it will actually execute the underlying method getAllTasks from this persistent storage. So let me just rename this. I'm going to say local storage persistent storage. Okay, now what is the point here? The point is that if I change the itasks persistent storage interface, this use tasks store, so this use effect method here, it is not coupled to this interface anymore. Okay, so if I change this, now what I have to do is I just need to update this getAllTasks method here. And I'm going to do the same for the save all tasks. And now this is again async. It gets a persistent storage, which is of type itasks persistent storage, and it does get tasks, which is of type array of tasks. And here it simply returns the persistent storage.saveAllTasks with my tasks argument. Okay, so now I can take this and I can execute it here at the bottom, and I'll simply say save all tasks, local storage, persistent storage, and the tasks I want to save. Now, this is one very, very small example of a principle called the dependency inversion principle. So the save all tasks, it does not, and the get all tasks as well. So these two methods, they are not explicitly declaring any of their dependencies. They are saying like, okay, I accept whatever persistent storage you pass as long as it conforms to this interface that it should conform. Okay, so the only thing is that it needs to implement these two methods. Where it's coming from, what it's doing behind the scenes, I don't care. I just want these two methods which follow these signatures. Now, this allows us to actually pass here the local storage, but in the future, we can very easily switch this for any network persistent storage, and we can even use two different ones here if we want to, as long as they follow the interfaces that we are defining here. So now you can see how interesting things start to get whenever we start actually looking into the design of the code. Here we are also being mindful that things will change, and we want to make these changes easy, right? So one step or one possibility of change is that the persistent storage will change in the future. So we are decoupling stuff, and we are making sure that we can switch this persistent storage whenever we want to. And the second step of this decoupling or making changes easy is that we are concentrating all the changes in a single place. So now if this interface changes, if for any reason we get instead of get all tasks, we're going to call this now fetch, right? Fetch all tasks. Then I need to update this, for example, fetch all tasks. But then the only place I need to update is this method call here. Look at my hook. My hook stays exactly the same. It doesn't change anything. There are no errors here because everything is abstracted by these utility methods. Okay, so here I would just have to say fetch all tasks and I'm good to go. And I apologize, I forgot to change another one that's in my tests, right? So my tests here, they should be the fetch all tasks. So once I save this, actually this one as well, fetch all tasks. Fetch all tasks. Once I save this will actually, now everything should pass. So let's give it a try. Maybe this is gonna fail because it didn't upload yet. Sorry, it didn't update. I changed it in the middle, so I'm gonna change it again and let's see what's gonna happen now. But all the tests should be green. Now you may be asking, should we put this in another file? Should we keep it here? Honestly, I'm just gonna keep it here. There is no need to add another file for that. If in the future we reach to a state where we do need to put these things in another file, I am fine with doing so. Okay, so again, let's not over-engineer things. Let's just keep things they are already over-engineered enough, I think. So let's just leave as they are. And when I look at this use tasks store here, then I can see that I'm satisfied with the result, and I hope you are too. If there are any questions, then always feel free to reach out in the comments. Let's just clean up a few things. And this we don't need anymore. So the serialized task is not here anymore. And then again, you see that we are dependent on interfaces all over the place, right? So interface, we always depend on interfaces and not on actual implementations, which is actually the recommended way to go. So good, I'm gonna save this once again. Maybe we can also remove this. So the number 3 is also done, which is great. And we can now remove these comments here. We can make sure that everything is looking good. I'm gonna save this, and then another comment, you see that all the local storage interaction, it happens inside of this local storage persistent storage file. There is nothing happening here, and that is great for us because then we can simply switch, right? We can just go away, like remove the local storage, put a network one once we get there, and we need to change very little in our existing code. Even better than this, maybe in the future, we're gonna put this inside of a context, and then we can retrieve it here inside of our component, and we don't even need to come into the task store here and change it. But for the moment, I think we are good to go. So let's stop this. I'm gonna run the test E2E local now, because I wanna make sure that the reload is still working as expected. And let's see how this plays in Cypress. Perfect, now everything is working. All the tests are passing. And actually, although I believe that Cypress does this local storage cleaning for us between the tests, but just to be super explicit about what's happening, I'm just gonna clear the local storage as well. Okay, so now let's have a look at all the changes we have done, and then let's commit them. So here I do have the commit view of my IDE. And once I open it, it allows us to just see the things that we have added. And we have added the reload test here. We have done a few changes on the index within our what's the folder here? The model folder. And then we have a bunch of new tests for the local storage, persistent storage test, the class file. We also have a new class which does this and implements an interface on being a tasks persistent storage. And we have a bunch of tests for our test, or actually one additional test for our task class. And that's because we needed to ensure the persistence of IDs. We have changed a few things in our task model. So now we have both static serialized and deserialized methods, which we can call to execute or to transform to move between a task class and its serialized representation. And then we added also the ID as an optional parameter here. And we have done quite a few changes to our tasks store, because now we have added persistent storage and we made sure that everything is decoupled and can be nicely used, nicely maintained, and nicely extended in the future. You may be shouting at me and complaining that we haven't opened the browser today. And as you can see, we don't really open the browser when we use we don't need to open the browser when we use the test-driven approach, because everything is tested now, but we can still try, right? I mean, we can try this, and then that's going to be my third task. And I'm going to show you something that happens here. So if I refresh it, if I close, and if I open it again, if I open it again, then they are still here. However, there is something missing, right? So if I mark a task as completed and I refresh it, I lose that state, I lose the state. So we are not persisting the completed state of a task. And that's what we're going to do in the next video. But I think that for today, the video is long enough. We have talked about a lot of cool stuff, and hopefully everything is clear. Once again, if it's not clear, comments down below. I'm happy to discuss anything that is unclear for you. Let's then, just to close up, we're going to run the format. We're going to just make sure that the linting is fine, and we will add everything, and then we're going to push to the remote repository. So let's add the whole bunch, and let's commit, let's say feat added persistent storage for tasks. Okay. Now this will again rerun the tests that I just ran. I just don't want to have to run them again. So now everything should be fine. And once that is done, I'm just going to push this to the remote repository. And once I do that, the changes will be deployed to the production environment in a bit, and you could actually play around with it. Everything is in GitHub. If we have a look at the repository, I believe it's this one, and we have a look at the code, then we should see that the tests, or that the CI/CD workflow is already running with our nice E2E tests, dev environment, and everything. So beautiful setup. Thank you, everyone. It was a great video, lots of information, lots of knowledge, and I'm looking forward to seeing you in the next one. Bye-bye.